Ocean currents are extremely complicated. Currents are inherently complex because they are affected by a variety of drivers. For example, winds are one of the primary drivers of surface currents in general. When the wind blows across the ocean surface, it transfers energy to the water surface, and this initiates some sort of a wave propagation. The second main factor is the Coriolis effect. This is more prevalent in higher latitudes. The Coriolis effect is due to the Earth's rotation. Instead of moving unidirectionally, the water will be deflected at an angle of about 45 degrees. The surface currents will be deflected to the right in the northern hemisphere and to the left in the southern hemisphere. Currents are also driven by differences in density. So for example, cooler, denser waters will sink, whereas the warmer and the less dense waters will rise, and this will create regions of upwelling and downwelling. Currents are also affected by tides. During the high tide, the currents will flow in the direction towards the coast, and then during low tide, the currents will flow away from the coast. The tidal currents are also further influenced by the coastal geometry. The shape line of the coast will influence where the currents flow. In shallower waters, the tidal currents will experience changes in speed. It is important to understand surface currents because surface currents are important in transporting heat, fish, coral larvae, sediment and nutrients around the globe. Surface currents are important especially for maritime hubs like Singapore, where there's a lot of ship traffic. Typically, we study current primarily by numerical modeling of the local hydrodynamics in Singapore. Due to modeling constraints, the effects of winds are not accounted for. Given the importance of winds, it is important that we do our best to include the effects of winds into our modeling.